Elon Musk's Starship is about to go orbital, and with its maiden voyage comes a whole new era of space exploration. So what does that mean for the decades of space work to come? That's what we're talking about in today's video about the SpaceX Starship. Welcome to our orbital future. The Starship program dates back to 2017, when Elon Musk unveiled his grand plans for a large, super heavy lift launch vehicle called the BFR, or Big Falcon rocket. This was as much of an ode to the company's current flagship rockets, the Falcon 9 and Falcon Heavy, as it was hyperbole. The key with BFR was that it was designed to get a lot of mass into orbit in one shot and then be reused many times, cutting cost drastically. Musk had proposed other concepts prior to the BFR announcement, including the proposal of the Mars Colonial Transporter, which would be powered by the unique Raptor engine. This was in 2012, around the time Raptor development was just beginning. In 2017, SpaceX was ready to announce the BFR, the super heavy lift rocket that would take hundreds of people and tons of supplies and equipment to Mars with the ultimate goal of developing a self-sustaining colony. In the years to come, BFR would evolve into Starship and Super Heavy, changing design every so often until we arrive at the present-day design. It's composed of two stages, the Super Heavy rocket booster and the Starship second stage. The Starship stands 50 meters tall and has a 9-meter diameter. It's capable of launching at least 100 tons to orbit and is designed to be reused. The Starship is fitted with 6 Raptor engines, 3 standard sea-level Raptors, and 3 that have been optimized to operate in the vacuum of space. The Starship also has a couple sets of fins. The large aft flaps and smaller canard fins on the nose help control the orientation of Starship during re-entry. And re-entry is a very hot process, with surface temperatures approaching 1500 degrees Celsius, which is why the rocket sports the blanket of black hexagonal heat shield tiles on one side. The Super Heavy booster also has a 9-meter diameter and stands 69 meters tall, because it's Elon we're talking about here. The booster is equipped with 33 Raptor engines and is capable of generating 7,590 tons of thrust. And even though SpaceX plans to reuse the Starship and booster like they do with their Falcon 9 boosters, neither will be outfitted with landing legs. Instead, SpaceX has somehow engineered a launch integration tower with chopstick arms capable of catching both ship and booster and planting right back on the launch mount for reuse. One of Musk's crazy tweets that has actually come to fruition. One of many. Anyway, Starship is going to become the new workhorse launch vehicle thanks to a number of disruptive innovations. First, its size. Starship has the largest payload capacity of any rocket for low Earth orbit. Depending on the payload's insertion orbit, Starship could bring anywhere from 100 to 150 tons to space. This will contribute to a lower cost barrier to space. The cost of one launch to bring 100 tons to orbit is generally less than the cost of 2 launches to bring 50 tons each into orbit, not to mention even more lower mass launches. But this is just step number 1 in cost reduction. Step 2 comes in the reusability of the vehicle. The more uses SpaceX can get out of a Starship, the cheaper the launches will be, and they'll be able to amortize the cost of the rocket over its lifetime. This means that after a certain amount of launches, the revenue from those launches will have covered most, if not all, the costs to build a rocket. SpaceX has already demonstrated this is possible with the Falcon 9 rockets, and now they are looking to apply the same principle at scale. This is step 2 of cost reduction. Along with reusability comes the rapid part. Musk wants to be able to refly ships and boosters as fast as possible and as many times as possible in order to increase efficiency and recoup costs. The ultimate long-term goal is for a single booster to be able to launch 3 times per day. That's 300 tons to orbit in one day by 1 booster and 3 ships. For reference, in 2021, SpaceX launched a combined 290 tons to orbit in 30 launches spread out over an entire year. Now, Musk wants to be able to do that in one day with only 3 launches and 1 booster. Rapid launch cadence is step 3 in cost reduction. Step 4 is rapid design iteration. From the beginning, Musk has aimed to use the cheapest materials possible and as simple of a design as possible. This allows the team to very quickly build, test, assess, iterate, and repeat. They conducted the 150-meter Starhopper test in the summer of 2019. The next summer saw the hops of SN5 and SN6, and in the winter of 2021, the high-altitude tests began. SN8, 9, 10, and 11 were all launched within 4 months, each performing well but failing to land successfully. A month later, SN15 launched to an altitude of about 12 kilometers, cut its engines, performed the belly flop maneuver to brake using the friction of air resistance, relit the engines, and landed upright on the pad. Now, over a year and a half later, the first orbital flight attempt is imminent. The pace of development here is outstanding, and it is thanks primarily to the iterative design methods employed by SpaceX. 6 years after it was announced, it is prepping for its orbital debut, from small hops to big landings to orbit in just 4 years. Meanwhile, Blue Origin announced its New Glenn rocket in 2016, a year before the BFR announcement, and shows no indication of launch readiness anytime soon. ULA announced the development of their Vulcan Centaur rocket in 2014, which is still in development, expecting a first launch this year. And it was 9 years after the formal announcement of the space shuttle that it made its maiden voyage. So clearly, this design method is proving to be effective. Another one of the most significant disruptive features of Starship is the engine. The Raptor engine is the only flight-worthy full-flow staged combustion engine to ever be developed. Now, if you aren't familiar with the physics of a rocket engine, this basically just means that the Raptor uses a unique method to achieve a higher level of efficiency than other rocket engines. In fact, the Raptor is the only engine able to use this method to propel a rocket. But the engine isn't the only efficiency improvement. There's also the fuel that powers the engine. SpaceX has opted to use methane paired with liquid oxygen to fuel Starship. Most rockets use either RP-1, also known as kerosene, or hydrogen fuel in conjunction with liquid oxygen. But both of these fuels pose their own various problems, and while methane doesn't necessarily outperform either one of them, it's a good compromise between the two. Now, we don't have nearly enough time to talk about why SpaceX chose methane over other fuels or all the intricacies of the Raptor engine. So if you are still hungry for more rocket knowledge, definitely check out Tim Dodd's video on the Raptor engine. It's hard to find someone who is explaining this high-level science in a way that pretty much anyone can understand better than the everyday astronaut. The link to that video is in the description. But there is one more noteworthy reason why SpaceX selected methane to fuel Starship. The ultimate goal is to use Starship to get to Mars, and Mars has abundant materials to manufacture methane propellant. This means you only need to bring enough fuel to get to Mars, and you can make the fuel to get back to Earth. This frees up more payload capacity for crew, equipment, and supplies. But Mars isn't the only objective SpaceX will use Starship for. In fact, I argue that deep space missions are one of the most impractical uses for Starship. And that is for one reason: the need for refilling. We know Starship can get 100 tons to orbit, but to get that to Mars would require full fuel tanks that were just emptied in order to reach orbit. So another Starship would need to be launched and transfer its fuel to the Mars-bound ship. But that ship's tanks aren't full either, and it turns out it would take about 9 or 10 flights alone to refill the tanks completely. How much fuel is actually needed to get to the destination, be it the Moon or Mars or somewhere else, depends on the destination. But until in-orbit refilling becomes hyper-efficient, we won't be sending fleets of Starships to Mars like Musk envisions. Until then, we need to utilize Starship for its most efficient use cases: getting things into orbit around Earth and returning to the surface for reuse as soon as possible. No money wasted on refueling. The majority of missions in the first years of its operations must be revenue generating. I include Starlink launches in this category because Starlink does generate revenue for SpaceX. But aside from Starlink, SpaceX will have a lot of commercial customers vying for launches. They already have an impressive client list, and I only expect it to grow as Starship becomes operational. One of the most important subsets of clients will be space station building companies and those venturing into orbital construction. I've said it before, and I'll say it again. Once we can build large structures in orbit, a whole new realm of possibilities opens up to humanity. And with Starship's record-breaking 9-meter payload fairing section, we will be able to launch larger instruments than ever before. For example, let's look at Orbital Assembly Corporation's Structural Truss Assembly Robot, or STAR, which is designed to build long segments of truss in orbit from start to finish. Their prototype is small enough to launch on a few rockets that are currently operational, but soon they'll want to build their truss to be as robust as possible, which means maximizing size. And Starship will enable a much larger version of STAR to be launched. We also know that there are at least 7 space stations currently planned, 5 of which are by commercial entities. It won't be long before they see the value of a large vehicle like Starship when launching their station modules and components. It's even possible that Blue Origin purchases flights on Starship for the orbital reef modules. If they can't get New Glenn operational in time to compete with other private space stations, they may turn to SpaceX, as they are the only launch provider capable of fitting the orbital reef components in the fairing section. Another reason SpaceX should be prioritizing low Earth orbit missions, especially in orbital construction, is that likely one of the first large projects will be an orbital fuel depot, allowing Starships and other vehicles to hit the gas station before heading out of town instead of finding 9 other cars to siphon gas from. This would hugely simplify interplanetary missions and even moon missions. Launch requirements would be reduced by an order of magnitude. That sounds like something Elon could get on board with. He loves improving by orders of magnitude. But what do you think? Will Starship's focus primarily be on low Earth orbit or deep space missions? Will SpaceX be supportive of orbital infrastructure projects? Let us know your thoughts in the comments below. If you enjoyed this video, hit the like button and consider subscribing so you don't miss the new videos we publish every week dedicated to building humanity's future in space. For now, check out some of our other videos, and we'll see you in the next one.